Let's see that in the last class we are discussed around 24 questions. Okay. Now today we will discuss about the remaining questions from level 3, alkyl halides and aryl halides chapter. Okay. Let's see the 25th question. It's very easy, dear students. 25th. Benzoyl alcohol. CH2OH. It is primary alcohol only because the OH group is attached at primary carbon. Alkyl aryl primary alcohol. This is reacts with SO2Cl2 thionyl chloride. What is the product? The X is benzyl alcohol is converted into benzyl chloride. Okay, CH2Cl. This OH group is converted into chlorine. That reaction is Darjan's process. Now the next one is it reacts with KCN, potassium cyanide. Okay, Cn minus will be attacked at this carbonyl carbon and Cl minus will comes outside. So it is nucleophilic substitution reaction. Now the product is CH2Cn. Okay, this is on hydrolysis in acidic medium. Hydrolysis H3O plus. That during the hydrolysis the Cn group is converted into completely hydrolyzed is converted into COOH. So the answer is CH2 bond COOH. Okay, 2-phenyl ethanoic acid. What is this IUPAC name? This is C option is correct. Its IUPAC name is 1,2 carbons. At 2 second carbon benzene ring is present. That's why it is called 2-phenyl ethanoic acid. Ethanoic acid. Okay. Let's go for next 26th question. It's very easy, ma. 26. The first one is elimination reaction. The second one is anti-Markovnikov addition reaction. And what is the product they are asked? Let's see tertiary butyl bromide. The 26. The first one tertiary butyl bromide. CH3 bond Br CH3 bond CH3. This tertiary butyl bromide is treated with alcoholic KOH. Alcoholic KOH. Loss of HBr. See, while treated with alcoholic KOH means dehydrohalogenation will take place. This halogen attached carbon is called alpha carbon. The adjacent carbons are calling as beta carbons. See here how many beta carbons are present. 3 beta carbons are present. At anywhere you have to remove one hydrogen atom. Then produce the product is loss of HBr. It is also called as beta elimination. The product is C double bond CH2 here bond CH3 and CH3 will comes. Okay. Now its IUPAC name is 2-methyl propene. Propene or prop1ene. Okay. So the next what we are doing, this product, this is X is treated with HBr, hydrogen bromide in presence of peracids or peroxides, H2O2. It is nothing but anti-Markovnikov addition reaction. Anti-Markovnikov addition reaction is free radical addition reaction. Free radical addition reaction. Okay, students, addition reaction. Now it is a hydrogen atom will be added at according to Markovnikov rule. According to anti-Markovnikov rule, the hydrogen atom is added at less hydrogens containing double bonded carbon, and negative ion Br minus is added at more hydrogens containing double bonded carbon. The product is CH bond CH3 bond CH3 bond CH2 Br. Okay, so its IUPAC name is methyl and bromine. According to alphabets, bromine name will comes first. That's why the bromine goes to more priority 1 and 2 and 3. So its name is 1 bromo 2 methyl 1 bromo 2 methyl propane to methyl propane. So according to that options, which is the correct structure, dear students, the structure is first option CH3 CH3 CH2Br. Okay, the first one is elimination reaction, dehydrohalogenation reaction. The second one is anti-Markovnikov addition reaction. Then the final product is 1 bromo 2 methyl propane is the product. Okay, let's see for 27th question. Which of the following halide would undergoes nucleophilic substitution more readily? Nucleophilic substitution reaction which will gives fast. They're asked. 27th question. First one 1 chloro, 1 butene. See, here the first option. Just you write the options first. Draw the structures of the all compounds. Butene means 4 carbon atoms. Okay, 1 chloro, this is chlorine, 1 chloro butanene. Okay, now this is a vinyl halide, vinyl chloride. This vinyl chloride is less reactive and aryl halides also less reactive. Alkyl halides, out of that, tertiary is more reactive than secondary and then primary. Compared to that alkyl halides, allyl and benzyl halides are more reactive. Now that second one is 2 chlorobutanene. This is here chlorine is present. It is also what type of, it is a primary vinyl halide, it is secondary vinyl halide, vinyl chloride. So it is also very less reactive. Next, the third one is 3 chloro 1 butanene. 1, 2, 3. Okay, and 4 3 chlorobutanene means it is a secondary allyl chloride. Secondary allyl chloride. Okay. Next, 4 chlorobutanene. This here chlorine will be present, so its position is 4. Just it is what type of compound? It is only just primary alkyl chloride. Primary alkyl chloride. So always this allyl is more reactive when compared to alkyl and then vinyl. So that's why the more reactive in nucleophilic substitution reaction is third option. So 3 chlorobutanene is more reactive because in SN reactions order benzyl is more than allyl and then alkyl. Alkyl groups, alkyl halides, and then vinyl as well as aryl halides. Aryl halides. So this is the reactivity order. So according to that allyl, secondary allyl, among that allyl chlorides or allyl halides, tertiary is more reactive than secondary and then primary. Among that all benzyl halides, tertiary is more than secondary and then primary. Here also tertiary is more than secondary and then primary. In alkyl halides, tertiary is more than secondary and then primary. So like reactivity order will comes. Okay students, so the answer is third option. Let's see the 28th question. The 28th question, CH3Br treated with Nu, nucleophile. What is that nucleophile and nucleophilicity order they are asking? Okay, CH3Br means it is a primary alkyl halide. Primary alkyl halides undergoes in SN2 mechanism. Now the product is CH3Nu nucleophile plus Br minus. It is SN2 reaction. Okay. Now the nucleophilicity order. Nucleophilicity order. Nucleophilicity order for SN2 is directly proportional to basic nature. Directly proportional to basic natures. Now given nucleophiles, let's see the acids, conjugate acids. What are the given conjugate acids? Phenol, PHOH, phenol. Now acetic acid, AC means acetic acid ma. CH3, C double bond O group is called acetyl group, AC, AC. OH. Okay. pH means C6H5. And then OH minus means water. And methanol, CH3OH. This is the corresponding conjugate acids. Now acidity order. Acidity order always carboxylic acids are more acidic. Carboxylic acids are more acidic. Let it is A and B, C and D. Okay, carboxylic acids are more acidic means B is more acidic. Its corresponding conjugate base is very more acidic. Phenol, PH, OH means A is more. And except methyl alcohol, the remaining alcohols are less acidic when compared to alcohols. That's why D is more. D is more acidic and compared to C. Now the basicity order. Basicity order reverse. B is more than A and then D and then C. C is what ma? OH minus ions. And D is nothing but methoxide ion, CH3O minus. And A is nothing but phenoxide ion. And B is nothing but acetate ion, CH3. Sorry, ACO minus. Acetate ion. Now the correct answer is C is more than D and then A and then B. First option is correct. Okay students, I hope you understood. So here never the nucleophiles they gave, directly nucleophilicity basic strength we can't identify. So in that case just you write their corresponding conjugate acids and write its acidic strength order. Then the acidic strength order is inversely proportional to basic nature order. Okay, so its conjugate base order will get. So among that, which is more basic nature, it acts as a strong nucleophile in SN2 reactions. SN2 reactions. The same nucleophilicity reverse will comes for SN1 reactions, because SN1 reactions nucleophilicity is inversely proportional to basic nature. So that related questions also be present. So that also we will discuss. Okay, let's see that 29 question same they gave. The correct order of SN2 reactivity order: water, CH3O minus, OH minus, and CH3COO minus. Among that, which is more basic? OH minus is more than CH3O minus, and then so the correct answer is OH minus is more than CH3O minus, and then acetate ion. CH3CO minus, because the negative ions are more nucleophilic strength when compared to neutral molecules. H2O is neutral and lone pairs only. The lone pairs on oxygen acts as a nucleophile. This is the correct base nucleophilicity order. Okay, so the 29. Let's see that the 29, the nucleophilicity order is OH minus ion. Okay, OH minus ion is more than CH3O minus, so the first option is correct. Next, 30th question. Let's see the 30th question. Which of the following is more reactive towards nucleophilic substitution reaction? Chlorobenzene 2, 4, 6 trinitrochlorobenzene and 2. Let's see the first one is chlorobenzene. The second one is 2, 4, 6 trinitrochlorobenzene. NO2, here NO2 and here NO2. 2, 4, 6 trinitrochlorobenzene. And 2, 4 dinitrochlorobenzene. Dinitro-chlorobenzene, and the fourth one is 2-nitro-chlorobenzene. 2-nitro-chlorobenzene. Okay, among that we have to identify the correct order, which is more reactive towards nucleophilic substitution reactions. See, these all are aryl halides. Means halogen is directly attached to the benzene ring. Those are called aryl halides. In aryl halides, nucleophilic substitution reactivity is directly proportional to electron withdrawing groups. If more electron withdrawing groups are present, it is more reactive towards nucleophilic substitution reaction. That's why the second option is very much high, because the more NO2 groups. These NO2 groups are electron withdrawing groups, or minus psi groups. That's why it is more. So if you want just there among that which is more reactive, only they are asked, but we can write the correct nucleophilic substitution reaction order also. We can write 2 is more when compared to 3, when compared to 4, when compared to 1. This is the additional one more. This kind of questions also they will ask. So however they are asking, but if you know the concept, then we can solve this kind of questions very easily. Okay, let's go for next question. 31. Which of the following compound gives enantiomeric pairs on treated with water? Enantiomeric pairs on treated with water. See, among that which is asymmetric carbon, then that gives chiral carbon containing. So the answer is chiral or asymmetric carbon. Asymmetric carbon containing alkyl halides. Alkyl halide containing tertiary alkyl halide or alkyl halide. Containing alkyl halide in SN1 reaction forms partial racemic mixture. Partial racemic mixture. Okay, students. So in SN1 reaction forms partial racemic mixture. So the racemic mixture means D and L. D and L are the non-superimposable mirror images. D and L are called enantiomers. D and L isomers are called enantiomers. Okay. Now among that which produce enantiomeric pairs, we have to identify that. See here, these two groups are same. That's why it is not optical active alkyl halide. Here ethyl and ethyl, two groups are same. It does not Now here ethyl and ethyl, it is also does not exhibits optical isomerism. See here C6H5, hydrogen and deuterium and benzene, phenyl ring and bromine. 4 different groups are present. Hence it is chiral carbon. Chiral or asymmetric carbon. Asymmetric carbon. Hence it produces enantiomers and forms racemic mixture. Racemic mixture. So the answer is a third option. Let's see that CH3, CH, D and Br. Sorry. C6H5. C6H5 bond H bond Br bond D is treated with OH minus. Hydrolysis is nothing but the nucleophile is OH minus. Now it is undergoes SN1 mechanism, and produce the front side H and D and C6H5 plus OH is on back side H and D. These are the what is the relation? This relation is non-superimposable mirror images. D and L. These are enantiomers. Okay, and 50% is unsymmetrical, means partial racemic mixture. Partial racemic mixture. For example, it may be 60% D, automatically it becomes 40%, or it may be 60% and it may be 40% like partial. Partial means it's not exactly equal quantities of D and L. So that's why it is called partial racemic mixture will forms in SN1 reaction when the alkyl halide having asymmetric carbon or chiral carbon. So here just we have to identify which organic compound, which alkyl halide having asymmetric carbon. Like alkyl halide is third one. Okay, then it is the answer. Okay, let's go for next. Next question. Among the following, which is undergoes more reactive towards SN1 reaction they are asked. See SN1 reactivity order. How can we identify? More stable carbocation. SN1 reaction order is directly proportional to stable carbocation. Stable carbocation, which can forms more stable carbocation, then it easily involves in SN1 reactions. Let's see this. C6H5 bond CH double bond CH3. It is secondary benzyl carbocation. Okay, now this is primary benzyl carbocation C6H5 CH2 plus. Next, the third one is, if you observe that this is alkyl chlorides, it is alkyl, these both are bromides, it is iodide. Okay, and one more thing is iodides are more reactive, and then bromides, and then chloride, and then fluorides are very less reactive. Only iodides, bromides and chlorides only we need to compare. So here also the carbocation is same. For the third one, the carbocation is C6H5 CH plus bond CH3. The carbocation is same, and fourth one carbocation is also same, C6H5 CH2 plus. But here the leaving group is iodine. Leaving group is iodine. Leaving group iodines are more reactive when compared with bromides and then chlorides. That's why third is more reactive. Okay, third is more reactive, and then here it is a primary, it is a secondary. That's why even though iodine is present, but secondary is more reactive than primary. That's why one is more than second, and second and fourth on comparison, fourth is more. So that's why 4 and then 2. So the answer is 3, 1, 4. 3, 1, 4, 2 means first option is correct. Okay, here clean important observation is important. The similar types of carbocations 2 are present, but one is iodides, another one is bromides. Iodides are more reactive when compared with bromides. So both secondary carbocations are forming, but one is iodide, another one is bromide. So iodides are more reactive than bromides. That's why 3 is more than 1. Next, second and fourth, they having similar carbocation, and in that iodide is leaving group, and another one is bromide, and bromide is more than iodide. Sorry, iodide is more than bromide. That's why fourth is more reactive when compared to second. When compared to second, so the answer is a first option. Okay, students. Okay, let's go for next question. 33. The correct reactivity order for the following SN1 reactions. See, it is also same. We have to identify that all are bromides only. It is primary benzyl carbocation. It is a secondary. It is secondary. It is a primary. Here two benzene rings are present. Here only one benzene ring, but it is a secondary. And here it is 1, 2 benzene rings with tertiary carbocation. That's why D is more when compared to all. See, if you observe the D options here, 1 and 2 comparison we need to check. Okay, D and D is correct. Now among that, D is very much high. Already we are identified. Now A, B, C we have to check. That A, B, C, A is primary and B is secondary, and C is also secondary, but here two benzene rings, two phenyl rings, here one phenyl ring, here one phenyl ring. Number of phenyl rings increases, the resonance will be increases, then the stability of carbocation will be increases. So compared to B and C, B is more when compared to C. That's why D is final. Next BC. Okay, next A. So the answer is first option. Like elimination process we have to apply, then we'll get a proper answer. Otherwise we'll be confused more. Okay. Now let's see that 34 question. Question also, correct reactivity order of SN1 reactions. See this chlorine, it will be breaks, forms positive charge. Here it will be breaks, forms positive charge. It will be breaks, forms positive charge. Now it contains propylium carbocation. Okay. So cyclopropenyl carbocation means it contains 2 pi electrons. It is aromatic. Means aromatic means 4n plus 2 pi electrons, where n is equals to 0, then 2 pi electrons present, 2 pi. N is equal to 1, 6 pi electrons. N is equal to 2, 10 pi electrons, like 10 pi electrons. So here n is equal to 0, then 2 pi electrons, it is aromatic. Here it contains, there is no aromaticity. Here no resonance. No resonance. And now here it is, the positive charge is present, it contains 4 pi electrons. 4 pi electrons means anti-aromatic. Anti-aromatic. That is 4n pi electrons. N is equals to 1, 2, 3, like that it will start, anti-aromatic. That's why aromatic carbocations are more stable than anti-aromatic carbocations. That's why one is more. This is 1 and 2 and 3, one is more are highly reactive regarding SN1 when compared to 3, then 2. So the answer is the first option is correct. Okay, students. So here first carbocations we need to observe which is more stable. So here resonance factor or aromatic carbocations are more stable than anti-aromatic because of aromatic compounds are more stable even though when compared with anti-aromatic. Aromaticity, how can you observe? 4n plus 2 pi electrons we need to check. Next, 35 and 36 last two questions. Let's see. Among that SN2 reactivity order, all are primary only. This is primary and this is also primary and this is also primary and this is also primary. Among that, iodides are more reactive than leaving groups. Leaving group order, iodides are more reactive than bromides and then chlorides and then fluorides. So among that, which is highly reactive? Ethyl iodide is more reactive. The nucleophilicity order in polar protic solvents. Polar protic solvents means SN1 reaction. SN1 reactions, nucleophilicity is inversely proportional to basic nature. Basic nature. So corresponding conjugate acids. Here HF is weak acid, then F minus is strong base. The answer is I minus is weak. So basicity order is I minus and then Cl minus and then Br minus and then F minus. So for SN1 reactivity order, I minus is more than Cl minus and then Br minus and then F minus. So the answer is third one. Okay, students. Okay, let's listen. And some other important questions also we'll do. See, we have to identify what is A and what type of reaction it is going on. We have to observe. OCH3 means anisole. Metabromoanisole is treated with sodamide. Sodamide is a strong base NH2 minus. Okay, just it removes at ortho hydrogen, ortho proton, and it eliminates Br minus and NH3. Okay, now forms one important intermediate, that is benzene intermediate. OCH3, this is benzene intermediate. Okay, students, it is very, very important. Benzene intermediate, how benzene intermediate is formed? By the elimination. By elimination. This benzene intermediate is treated with ammonia, NH3. This it will be attack at meta position. Attack at meta position means nucleophilic substitution reaction. Generally, aromatic compounds are less reactive in nucleophilic substitution reaction. When they have, but when treated with sodamide, they forms benzene intermediate. This benzene, due to the formation of benzene intermediate, they can able to involve in nucleophilic substitution reactions very easily. Now the final product is OCH3 metamethoxyaniline formed by the substitution reaction. What type of substitution this is? Nucleophilic substitution reaction. It is nucleophilic substitution reaction. So the answer is D. So here elimination they not give. First option, let's say ortho position not possible, and elimination addition reaction. Here not addition reaction, it is syn substitution reaction. It is not a syn substitution reaction and bromine will not form. Okay, so this product is wrong. Next, syn substitution. Syn means same side. So here this is not a correct product. The correct product is fourth option and it is a nucleophilic substitution reaction. Okay. So this kind of questions also very, very important. Let's go for next question. Consider the reaction. This is primary alkyl bromide or alkyl halide reacts with NaCN. Means what is the reaction? This reaction is primary alkyl halides reacts with nucleophilic substitution reaction, means SN2 mechanism. SN2 reactions are favorable polar aprotic solvents. Polar aprotic solvents. Polar aprotic solvent, that is DMF, dimethyl formamide. HC double bond OH, bond N, bond CH3, bond CH3. N comma N dimethyl formamide is known as DMF. Okay, so the DMF is more polar aprotic solvent, is favorable for SN2 mechanism. So what is the solvent? Ethanol is a protic. It can produce H plus ion. Methanol, it can produce H plus ion. Water also it can produce H. These are the polar protic solvents. Ethanol, C2H5OH, methanol, CH3OH, and water. These are polar